Hi, so this is my design process, and basically where I started off was just a simple sketch in my notebook, and this was just really like a platform on a rail, and that's really the entirety of that sketch. And yeah, so after that, I kind of stepped up a level and started CADing the design. Um, so a lot of these parts were already available online, and I didn't want to spend time, recading it because it's a programming project, but um, basically I had to adjust a few things, so like the screw size and the dimension of the project and the items itself, so that it fits my project. And as you can see here, I had so many failed attempts in printing these, and yeah, so every single failed attempt was a new thing for me to overcome. And yeah, it was really cool 3D printing all of these, because one of my biggest inspirations is also a 3D printer itself, for the design of the system. Because if you think about it, a platform and 3D printer is kind of similar to the platform I bring back and forth in the bartender, but using a stepper motor, and a lot of the design was inspired by that. And as you can see in this picture, I actually got my nozzle clogged once, and so yeah, I had to disassemble the hot end and take out that filament. But it was a really cool process. And over the time that I printed, I'd say about 1 kilo of PLA. So that was really cool. It was really my first experience in 3D printing in that of a large scale. So yeah, thank you. Hi, so this is the assembly section where I talk about the parts, and as you can see here, this is all the parts I use, and a few things I want to highlight is the NEMA 17s, and those are basically the stepper motors that I use for controlling the platform movement and also the upward movement. And also a really important part was the optics, and that's basically what poured the liquid. So if you move a platform up and you go to a certain level, the optics pour a certain amount, which is 40 milliliters in my case. And yeah, it was really important for my project as a whole. So thirdly, you can also see the threaded stepper motor gears, and basically that propelled the rail back and forth, which you can see in a little circle there, and that's what allows for the platform movement, and also allows for the rails, the linear shafts to be ridden without any manual forces. So yeah, that's really the main parts of it. You can also see the 3D printed parts that I have, and those are basically all the ones that I 3D printed. One of them broke, and yeah, that's unfortunate, but I had to also reprint a few things, so that's fine. So yeah, thanks. Really happy with that. This is basically a recording of me um, putting in my first wire into the breadboard, and that was a really exciting moment for me. So, see, and also the LED works now, so that's good. It's basically just controlling this stepper motor here. It's a NEMA 17, and you see this like spinning a little bit. That's causing this to move a little bit. It's very subtle, but you can see it moving. So I just finished programming the limit switch, and I'll show you how it works. So this is the limit switch, and when you press it, it'll send the output to the serial monitor, and that's shown here. I'm pressing it right now, number button pushes 3. It's really cool, pretty cool for me, but yeah, that's it. Hi, so this is the programming part of the video, and basically I'm going to talk about the code right now. So this is the Arduino IDE, and this is the one that I use for sending the code to the Arduino Uno R3. And basically the first thing I did was instantiate include. It's kind of like import in C++, the Adafruit library, and yeah, that's one of the main ones that I use, especially for the stepper motors, and because it's connected directly to the motor shield. And so this is instantiating the stepper motors, the limit switch, the green pin, red pin, and blue pin for the LED. And these are just the optics. This is a 2D array, kind of like the AP comp size, you know what I mean? And it's basically instantiating a drink matrix with the optic count and also the parameter count, meaning the amount of parameters that each input takes from the serial monitor. And basically this is a boolean to see if the limit switch is found when when originally the x-axis going all the way to the right. So the way it starts is by instantiating the serial monitor, and that's by doing this. This is just a default code. It's dictated by the BOD, and my BOD is 9600. So yeah, I put that. And yeah, this is just debugging information. If the motor shield is not connected, it'll send a message to the serial monitor saying it's not connected. So yeah. So the pin mode, this is just a LED method, and basically what it does is instantiate the LED limit switch and also the built-in LED as a certain pin, and it's output or input. So all of these were found on the website. And yeah, so and lastly, this is the setting the speed of the motor, both stepper motors. So yeah, so let's get into the real code now. So if the limit switch isn't found yet, meaning that the robot isn't all the way to the right, KetanBot will tell the robot to go all the way right based on the last reading of the limit switch, basically if it's false or true, and it steps forward 10 degrees until it gets to the rightmost position. And this is the way I did it. So yeah, that's the code that brings it all the way to the right. And this is a drink requested code, and this is basically when you input order to the program, and this is through the step to the serial monitor. And what it does is basically search linearly through array. And so I can put 3 parameters, and that's the drink matrix, meaning where the optic is found, if it's forward, and if it's double, and that's basically the way stepping works. And so in the serial monitor, I say a certain distance, a certain amount, a certain time, and basically it stays there for that time as dictated here, and it gets that amount of quantity for the third parameter. And yeah, so that's based on this, and I don't know if I'm explaining it that well, but it does that until the limit switch is found again, which is basically when the order is finished. So after the order is finished, KetanBot tells us that he prepared your drink and enjoy, and it sets the color to green. So when the limit switch is activated, drink request is equal to false, and basically what it does is set the serial number to 40 it subtracts 48 from the serial monitor, meaning that we can access it now. And basically it asks the serial monitor, do you want a drink? And if you do input something like one of these CSV files, which is what you input here, then you can get your drink. And so yeah, so based on that, it sends this code to this code as drink request is turned on, and meaning the boolean is turned to true, and it starts moving. So yeah, once you finish inputting, KetanBot tells you that you finished inputting, and it prints the array. And basically it's just a simple printing array code. It's just a recursive, not a recursive, but it's like 3D. It's like printing a 2D array, and what it outputs is this. So yeah, it's just for debugging information. And yeah, so I don't have any comments in this version, but I'll add comments and upload that to the GitHub. Thank you. Hi, so this is a website I made, and I made it on Coding Rooms, and it's not that complex of a website, but I'll show you right now. So this is my website, and so I have a few files, and these are all pages that I made, and a few images, of course. But yeah, so I'll just show the website right now. But so right now it's just a home page with my inspiration, purpose, and the video to a link to this video. And it has a about me page. It's this using a flexbox, and just tells a few things about me, my name, and this is a picture of me in Australia, and yeah, this is one of the mentoring events I did. So yeah, that's the about me page, and The way I themed this entire website, if you're wondering, was based on the coding club themes. So yeah, that was cool. And so here's my research procedure, and basically this is the procedure I followed to think of my idea and try to make it um, work physically. And yeah, so first I sketched it, did some background research, and then found the hardware and software components, made a wiring diagram, and then finally assembled it. So this is my page for prototyping. All these pages were made using Flexbox or some sort of grid, and yeah, so for prototyping, it talks about how I use 3D printing and how I had so many failed prints, um, and how I just kept testing the 3D prints out in CAD and seeing if it works. And yeah, this one, the final prints I made. This one took 13 hours to print, if you're wondering. But yeah, so this last page is not that big of a programming page, but basically it talks about an overview, objectives, and implementation of the programming. And I talked about the programming more in the video in the previous section, but basically it tells you that the programming code controls the KetanBot's movement and recipe database, which is basically the motors, pins, and sensors necessary to pour the drinks. And so the code that I use is basically to get your drink from the cereal monitor and then move it on the platform physically, and that's really cool in my opinion. But yeah, so here it talks about the implementation as well, how I use a 2D array, like Adafruit motor shield library. And yeah, this is the website I made. So here's the code I made. So the way I did it was having hrefs, and basically that links to a page which could either be home, and research.html about project, prototyping, programming. And here's the way I made it. The CSS file was a lot of work for me, at least. The HTML wasn't that hard, but this was a lot harder in my opinion. But basically the way it works is by assigning nav, li, and a few things to all of these programming.html files and index.html, like the nav, header, main, h1. I have that all here. So I styled it like the way it is right now, with the coding club themes. And if you notice this image, you can see that it's a little slant, like this little cutoff here, and that's one of the visual techniques I did using CSS. So that's cool. And yeah, so I uploaded the images, wrote a few things in each section. Just go through that now, and yeah. So yeah, thank you for watching this video. It was really fun to make, especially editing this video. So thank you for watching. Bye.